Welcome to the deep dive. Today, we're diving into the world of digital twins.
Oh, cool.
Yeah. You know that tech kind of blurring the lines between real and virtual?
Right.
We've got a chapter straight out of the 2024 book Digital Twin by Yan Zhang. Let me tell you, this stuff is cutting edge. We're talking virtual versions of like actual objects and systems.
Yeah, really changing things up.
It could revolutionize so much, from manufacturing to healthcare.
It really is amazing how fast this idea is going from theory to like actually being used in so many industries.
Exactly. So for someone who's like, digital twin, what's that?
Yeah.
What is a digital twin? Like, is it just a super fancy 3D model or what?
Well, it's definitely more than just a static model, you know?
Right.
Think of it like a dynamic living mirror of a real thing. Every little change, every fluctuation in the real world, it's all reflected in its digital twin.
Whoa.
Almost instantly.
Okay, so that's pretty mind-blowing. So if I made a digital twin of like a bridge, it'd show me like in real time if there was any stress or damage.
Precisely. That's one of the big benefits, always monitoring and analyzing.
Right.
But it's not just about seeing what's happening.
Right.
Imagine using that data to predict problems before they even happen.
So like preventative maintenance, catching issues before they become huge disasters.
Exactly.
That's super powerful. The book mentions this idea isn't exactly new though, right?
You got it. The concept's been around for a bit. Michael Greaves, back in 2002, kind of laid the groundwork with his product lifecycle management idea. And NASA, always the innovators, they were early adopters using digital twins for space exploration.
That makes sense. When you're dealing with the complexities of space travel, you'd want every edge you could get.
Absolutely.
So if I wanted to build a digital twin, what are the must-haves? Like, what makes it work?
All right, so there are three core components.
Okay.
First, you have the actual thing itself, right?
Right.
Could be a simple machine or a whole factory.
Yeah.
Then you have its virtual representation in the digital world, the twin.
Got it.
But the real magic is in the third part, the constant flow of data and information connecting them.
That data link is what keeps the twin in sync with reality.
Yes.
So I'm guessing things like sensors and the Internet of Things are key here.
Absolutely. Sensors are constantly gathering real-time data from the real object.
Okay.
Temperature, pressure, vibration, anything relevant. This data then gets sent to the digital twin, keeping it up to date.
So it's like a live conversation back and forth between the physical and digital.
Exactly. And it's not just one way.
Oh.
The digital twin can send instructions back to the real object.
Really?
Yeah. Based on all the data analysis, the twin might suggest adjustments,
Wow.
to optimize performance or prevent a malfunction.
Okay, this is starting to sound straight out of science fiction.
I know, right?
But the book highlights some real-world stuff too, right? Like, what are some actual applications that are happening today?
Oh, definitely. One area where digital twins are making a big splash is smart manufacturing.
Oh, interesting.
Imagine a digital twin of a whole factory,
Wow.
showing you every machine, every process in real time. You could pinpoint bottlenecks, optimize workflows, even run simulations to test new configurations.
So it's like having a virtual sandbox to play around with your factory and find ways to make it better.
Precisely. And it goes way beyond just manufacturing.
Oh,
Imagine a digital twin of a patient in healthcare. Doctors could simulate treatments, constantly monitor vital signs, even predict potential health issues before they become critical.
That's incredible. Personalized medicine taken to a whole new level.
Right.
What are some other areas where this tech is being used?
Another really exciting area is the development of 6G networks.
Oh, yes.
With the explosion of data and the need for lightning-fast communication,
Right.
digital twins can help manage the insane complexity of these networks,
I can imagine.
optimizing data flows and ensuring everything stays connected.
Yeah, it sounds like we're talking about managing a massive interconnected ecosystem,
You got it.
not just individual objects anymore.
And that's where the potential of digital twins really shines.
Yeah.
When you start thinking about networks of interconnected twins all working together, that's where things get really transformative.
Okay, I'm definitely intrigued. But let's say someone wants to build a digital twin for their business.
Yeah.
What are the different ways they can approach it?
There are two main approaches, specific modeling and general modeling. Specific modeling is like tailor-made for a very particular purpose, optimizing the energy efficiency of a specific machine.
Got it.
General modeling is more versatile.
Okay.
You can create a digital twin that represents a wider range of systems and how they interact.
So if you have a very specific problem to solve, you go with specific modeling.
Right.
But if you want a more flexible, adaptable twin, you go with general modeling.
Exactly. The choice really depends on your needs and how complex the system is that you're trying to represent.
Makes sense. I'm guessing there are different software tools and platforms out there for building these twins, too.
Absolutely. Lots of options depending on the complexity and purpose of your digital twin.
Okay.
For general modeling, Modelica is a popular choice.
Hmm.
While tools like AutoMod and FlexSim are often used for more specific applications.
Right.
But choosing the right tools is just one part of it.
I was going to say, it's not just about the tech, right? There are other challenges to building a good digital twin.
For sure.
What are some of the things people need to be aware of?
Well, one of the biggest hurdles is capturing the complexity of the real world.
Yeah, I can imagine.
All the variables, the interconnectedness, the unexpected events,
Right.
It's a huge task to represent all that accurately in a digital model.
It sounds like you got to find that balance between capturing enough detail to be useful,
Yeah,
but not getting bogged down trying to model every little nuance.
exactly.
And then there's all the data generated by these twins.
Oh, yeah.
We're talking a constant flood of information.
Huge amounts.
That needs to be processed, analyzed, and acted upon.
You got it.
Data management is a huge challenge already.
It is.
And it seems like digital twins just amplify that.
Absolutely.
But I guess even with these challenges, the potential benefits are so big that research and development just keep pushing forward.
They do. It's an exciting field.
Okay, so we've covered what digital twins are, how they work, and some exciting applications.
Yeah.
But I have a feeling we're just scratching the surface here.
Oh, we are.
Now that we've got the basics down, we can dive into some of the more cutting-edge stuff.
Yeah, let's get into it.
Like how artificial intelligence is taking digital twins to a whole new level.
AI and digital twins, that's where things get really interesting.
Now, that sounds like a recipe for some serious innovation.
It is.
Stay tuned, everyone, because we're about to get even deeper into the world of digital twins.
I can't wait.
All right, we're back, ready to see how AI is changing the world of digital twins.
Yeah, it's really exciting stuff.
I bet. This is where the real magic happens, right?
Definitely. Combining AI with digital twins opens up so many possibilities.
Oh, yeah.
It's like giving these virtual representations their own brains, Enabling them to analyze data, learn, even make decisions on their own.
The book talks about AI enhancing these digital twin edge networks.
Right.
Can you break that down a bit?
Of course. Imagine a self-driving car, right?
Okay.
It has its digital twin.
Yeah.
But for the car to make split-second decisions, it needs to process info super fast.
Right, sure.
Sending data to some far-off server and waiting for a response, that just wouldn't work.
So edge networks are about bringing the computing power closer to the action.
Exactly. Think of it like mini data centers right there next to the physical objects.
Mm-hmm.
This allows for real-time processing and decision-making.
Got it.
And that's where AI comes in.
Okay, so instead of just mirroring the real world, these edge-powered digital twins can actually use AI to analyze data and make decisions.
Right, like giving them a brain, remember?
Right. So what kind of AI are we talking about here?
The book dives into three main types.
Yeah.
Deep reinforcement learning, DRL.
Okay.
Federated learning, FLL. And transfer learning, TL.
Okay, so DRL first. I'm picturing, like, robots learning kung fu in a virtual dojo.
Haha, not too far off, actually.
Really?
Think of it this way. You create a digital twin of the environment where you want a machine to learn.
Okay.
Like a factory floor or a busy intersection.
Got it.
Then you let loose a DRL agent in that virtual world.
So the DRL agent is like a virtual robot.
Yeah.
Learning by trial and error in the digital twin.
Exactly. No real-world crashes or explosions.
That's good.
The agent tries different things, gets feedback, and learns what works best to reach its goal.
So like optimizing a process or navigating traffic, all virtually.
Exactly.
That makes sense. But what if you need tons of data to train these AI models?
Yeah.
Wouldn't that be a logistical nightmare?
That's where federated learning comes in handy. Imagine a fleet of delivery drones, all equipped with sensors, gathering data.
Okay, so we have tons of data spread across all these different drones.
Right. With FL, each drone can train an AI model locally on its own data. Then, only the insights from that model, not the raw data itself, are shared with the central server.
So each drone contributes a piece of the puzzle, and the server puts it all together to create one super smart model.
Exactly.
Without compromising anyone's privacy.
Precisely. It's a game changer for training AI in the real world.
Yeah.
especially where data privacy is a big concern, like healthcare.
Right. You can't just be sharing sensitive patient info.
Exactly. FL lets you use data from many sources without compromising confidentiality.
That's pretty clever. So we've got DRL learning through virtual experience
Right.
and FL training collaboratively.
Yeah.
What about transfer learning?
Transfer learning. Imagine you've spent years training a digital twin
Okay.
to optimize a specific type of wind turbine.
Right.
Now a newer model comes out with some design changes.
Oh, so do you have to start the training process all over again?
Not necessarily. Transfer learning lets us take what we learned from the first twin and apply it to the new one. It's like saying, hey, you already know a lot about wind turbines.
Right.
So use that knowledge to learn about this new model faster.
That could save so much time and resources.
Absolutely.
So with these 3 AI techniques, digital twins can learn from experience, collaborate,
Yeah.
and even build on existing knowledge.
It's really amazing.
Pretty impressive.
It is. But as we get deeper into this world of intelligent digital twins,
Yeah.
we need to make sure the data they rely on is secure and trustworthy.
That brings up a big question. Data security.
Right.
With all this information flowing between the real and virtual worlds, how do we keep it safe?
That's the key question. And that's where blockchain technology comes in.
Oh, blockchain.
Remember how we talked about blockchain's ability to create a tamper-proof record?
Yeah, like a digital ledger that can't be messed with.
Exactly. Now imagine integrating blockchain into a digital twin network. Every interaction, every data exchange is recorded on the blockchain,
Okay.
creating a secure and auditable trail.
So if someone tried to tamper with the data, it would be super obvious.
Right, because it wouldn't match the blockchain record.
That makes sense. This level of transparency and security seems crucial.
It is, especially in sensitive areas like healthcare or supply chain management.
Definitely. The book gets pretty technical about how blockchain can be integrated into digital twin networks.
It does.
It mentions optimizing the transaction confirmation process to keep up with the real-time nature of digital twins.
Right, because traditional blockchain transactions can be slow,
Yeah.
but in a digital twin environment, you need things to happen quickly.
Right.
So researchers are working on ways to streamline that confirmation process without sacrificing security.
So we're talking about a world where data is not only secure, but also flows seamlessly between the physical and digital.
Exactly.
What are some potential downsides to all of this, though?
That's a good question. Like any powerful technology, we need to be careful.
Of course.
One concern is bias in the AI algorithms powering these digital twins.
Right. If the data used to train the AI is biased, the digital twin could just continue those biases.
Exactly. It could lead to unfair outcomes.
That's a scary thought.
Yeah.
We need to make sure the data is representative.
Yes.
And that the AI models are fair and unbiased.
Absolutely.
Especially as we rely more and more on these systems, we need to ensure they reflect our values and serve everyone fairly.
I agree. Ongoing research and ethical discussions are really important here.
Definitely. We need to always be evaluating the impact of these technologies and make sure they're being used responsibly.
Absolutely.
This is all so fascinating. We've gone from the basics of AI to the complexities of blockchain.
I know, it's a lot.
I feel like there's still so much more to explore.
There is.
Next, we'll delve into some specific examples of how these AI and blockchain-powered digital twins are being used in real-world networks.
Okay, sounds good.
Like 6G and those aerial ground networks.
It's really interesting stuff.
From self-driving cars to delivery drones, it sounds like we're entering a world where the lines between physical and digital are completely blurred.
It's getting harder and harder to tell them apart.
Stick with us, everyone, because this deep dive is about to get even more exciting.
Can't wait.
Okay, so we're back and ready to dive into some real-world examples.
Yeah, let's see how these digital twins are actually being used.
I'm especially interested in what the book says about 6G networks.
Oh yeah, 6G is the big one.
That's the next generation of internet, right? Super fast connections and all that.
It is. It promises crazy speeds, basically instant communication.
Wow.
And the ability to connect billions of devices all at once.
Billions. That's insane.
Think about it. Everything's connected.
Yeah.
Your fridge, your car, constantly sharing data and interacting.
That's mind-boggling, just the scale of it all.
It is. It's massive.
So how do digital twins even fit into that? Like, how can they help manage something that complex?
Okay, imagine trying to manage traffic in a city.
Okay.
with billions of cars all talking to each other and things like traffic lights.
Right.
It'd be a nightmare without some smart system to control it all.
Yeah, total chaos.
So digital twins can act as a kind of traffic controller for all that data, making sure everything runs smoothly.
So like air traffic control, but for data.
Yeah, something like that.
That's a good way to put it. So they help predict and manage network traffic.
Exactly.
Making sure things are running efficiently.
Right, and they can even spot potential problems before they cause any real issues.
So it's not just about reacting to problems.
No.
It's about preventing them in the first place.
Exactly. You're getting it.
The book also mentions these reconfigurable intelligent surfaces, or RIS.
Oh, yeah, RIS is pretty cool.
What are those? I don't think we've talked about those yet.
Okay, so imagine a wall that can reflect and manipulate radio waves
Okay.
to make signals stronger and improve coverage. That's basically what an RIS does.
So by creating a digital twin of the RIS and its surroundings, we can make sure devices are always connected to the best signal.
Exactly. You can optimize its configuration in real time.
Wow, so it's like having a network of smart antennas that can adapt to changing conditions.
You got it.
That's really impressive. And the book talks about using this for something called computation offloading.
Right, computation offloading.
What is that exactly?
Okay, let's say you're streaming a high-def video on your phone.
Okay.
That takes a lot of processing power.
Right.
With computation offloading, your phone can basically hand off that task to a nearby server with more power.
So like an edge server connected to the 6G network.
Exactly. It's like teamwork for data processing.
The phone says, help me out here, and the network steps in.
Exactly. And a digital twin can figure out the best way to do that, taking into account things like signal strength, available resources, even your location.
So it's all about making sure things run smoothly behind the scenes.
Yeah, giving you the best possible experience.
That's pretty cool. And this is just one example of how digital twins can be used in 6G.
Oh yeah, there are tons of applications.
Like what?
They can optimize energy consumption,
Okay.
improve security, even test out new network configurations without affecting the real network.
So they're pretty essential for making 6G a reality.
I'd say so. They're a key part of it.
And it's not just about 6G either.
Right.
The book also talks about digital twins being used in these aerial ground networks.
Yeah, aerial ground networks are another exciting area.
So we're talking about things like drones, right?
Yeah.
Delivering packages, inspecting infrastructure.
Exactly. Drones, balloons, all sorts of things.
That's wild. So how do digital twins help with those networks?
Let's say you have a bunch of drones monitoring a wildfire.
Okay.
By creating digital twins of the drones, the terrain, even the fire itself.
Wow.
You can coordinate their movements, optimize data collection, even predict how the fire will spread.
So it's like having a virtual command center for the drones.
Yeah, you can see everything and make informed decisions.
That's incredible. And just like with 6G, digital twins can help with task offloading in these networks too.
They can. If a drone needs to process a lot of data, it can hand it off to a ground station or another drone.
So they can focus on their main missions without getting bogged down.
Exactly. It's all about maximizing efficiency.
And beyond disaster response, these aerial ground networks can be used for all sorts of things.
Oh, yeah. Tons of possibilities.
Like package delivery, right?
Exactly. Imagine a fleet of delivery drones, each with its own digital twin, navigating a busy city.
It's like air traffic control, but for drones.
Pretty much. Making sure they don't crash and get to their destinations quickly.
And because the digital twins are constantly updated,
Right?
they can adapt to changing conditions, like traffic or bad weather.
Exactly. They're always learning and adjusting.
This is amazing. We've gone from digital twins mirroring single objects to managing entire networks.
It is pretty incredible, isn't it?
It really shows how fast this technology is evolving.
And the potential is huge. It's really going to change how we do things.
All right, so we've taken a deep dive into the world of digital twins.
We have. It's been a great discussion.
We've seen how they work, how AI is taking them to the next level,
Yeah, AI is a game changer.
and how we're revolutionizing these complex networks.
It's clear that digital twins are more than just a cool tech gadget.
Right, they represent a whole new way of thinking about and managing complex systems.
Absolutely. They're changing the game.
We've covered a lot today, but I want to leave our listeners with something to think about.
Okay, what's that?
As digital twins become more advanced and intertwined with our lives,
Yeah.
it raises a big question. What does it mean to be human in a world where the lines between physical and digital are so blurred?
That's a deep question.
It is, and it's something we need to consider as these technologies keep developing.
We need to have those conversations now.
Absolutely. A huge thank you to our expert for taking us on this journey.
It's been my pleasure.
And to our listeners, keep those minds curious, because the world of digital twins is just getting started.
There's a lot more to come, that's for sure.
Until next time, happy exploring.